Hey everyone, in this video I'm going to go over adding and subtracting radicals. The most important thing about adding and subtracting a radical is that the radicands, which is the insides of the radical, need to be the same, and the indexes also need to be the same. If those are the same, then you can add the radicals. So for my first example, I do see the same index and the same radicand, so all I'm going to do is subtract 8 and 2, and 8 minus 2 gets me 6, radical 7, and that is my final answer here. The next one's a little bit different because if you notice, I have a radical 5, but then this is a radical 3. Now because it's a radical 3, I cannot combine it with the other radical 5. So what I'm going to do is I'm going to add the radical 5s because they're like terms. In front of my first radical 5 is a 1, so I'm going to add 1 and 4 to get 5 radical 5s. And then I'm going to just add the 2 radical 3 to the end because it is not like, and it does not combine with the other radical 5s. So I have 5 radical 5 plus 2 radical 3. The next question, if you notice, my first example does not have like radicals. One has a radical 5 and the other one has a radical 45. So what I'm going to do is I'm going to reduce the ones that I can. Radical 5 cannot be reduced. There's no factors inside of it that is perfect, so it's just radical 5. But radical 45 can break up into 9 and 5, allowing me to be able to reduce this part of the expression. So I'm going to pull down 10 radical 5 again because I can't reduce it any longer. But with this part, I'm going to make the radical 9 a 3, keep the radical 5 because he does not reduce anymore. Again, I'm going to pull down 10 radical 5 because I can't do anything with it. But I'm going to multiply 3 and 7 to get 21 radical 5. And now, if you notice, I have a radical 5 and a radical 5, making these like radicals. So what I will do is I will do 10 minus 21, giving me a negative 11 radical 5. The next question that's on the slide is also different. The radicands have both x to the 4th, but they have different numbers inside. So what I'm going to try to do is reduce the radicands so that I can add my terms if they become like. So if I notice here, I do notice a few things. I'm inside of a square root. I'm going to pull down this 5. Because I'm inside of square root, I can take the square root of 16, which is just 4, and the square root of x to the 4th, which is x squared. I'm going to have plus 3. The square root of 25 is 5. And the square root of x to the 4th is x squared. With each term, I'm going to multiply the coefficients. So 28x squared plus 15x squared. And now I have like terms because they're both x squared. And that'll end up getting me 35x squared. My last example in this video has different radicands. So I cannot add them the way they are. I do have to simplify each radicand. So what I'm going to do is I'm going to deal with each of them separately. On the first one, the b will stay because it's on the outside. I'm going to break up 45 into 9 and 5 because 9 is the perfect square inside of 45. C cubed, like in my previous video, when you have an odd power underneath a square root, you will break it up into the first even power and then what's left over, plus 4c, because it's outside. 20 will break up into 4 and radical 5. And b squared just becomes b, because the square root of b squared is b. And then radical c is not perfect, so it will stay inside the house. I'm going to drop down this b, make the 9 a 3, radical 5. The c squared will become c, radical c, plus 4c. The radical 4 will become a 2, radical 5, b radical c. So now I'm going to clean up each part of the expression by multiplying and bringing everything that is not inside a radical to the front. So my first piece, I noticed that b, 3, c are all outside. So I'm going to rewrite this as 3, b, c. And then the radical 5 is still inside of a radical, and the c is still inside the radical, plus the 4 and the 2 I can multiply to 8, And again, I have a c and a b on the outside. So I have b, c, radical. There's a 5 left over in the house and another c. Now if I look at my two terms, they're exactly the same because they have the same radicand, which is 5c, and they have the same variables outside, which is b and c, and the same index because they're both square roots. So what I can do is I can just add the coefficients. So 3 plus 8 is 11, and that becomes 11bc, the square root of 5c. I hope this video helped. I'll see you guys soon.